Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. I welcome you all into my today class. Our today class is about the basic forces of nature. So let us start with the name of Allah Almighty. Uh, the There are four basic forces of nature: gravity, electromagnetic force, the weak force, and the strong force. And except the weak force, I introduce the other forces in some way or the other, particularly the electromagnetic force in much great detail, and to somewhat the nuclear force also. But here in this lecture, I will give detailed description of all the forces. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. I would like to begin my lecture from the picture taken by the NASA. Here you see the four fundamental forces of nature at the root of every interaction in the universe. So this implies that without these forces, maybe there would be no universe, rather we wouldn't exist. So what I can say that here I quoted some from that NASA website, uh, that from walking on the street to launching the rocket into space to sticking a magnet on your refrigerator, physical forces are acting all around us, but all the forces that we experience every day and many that we don't realize we experience every day can whittle down to just four fundamental forces, and they are gravity, the weak force, and the electromagnetism, and the strong force. And I would added one or two sentences from my own side to their NASA statement that these are called the four fundamental forces of nature, and they govern everything that happens in the universe. And simply, I would like to tell you that without these forces, all matter in the world will fall apart, means the universe wouldn't exist. So let us start first with the gravity. That what is gravity? Gravity. Now, that is gravity or the gravitational force. It is the force of attraction, or it is the force of pull between all kind of masses, between all kind of masses. Between what? Between all kind of masses. And I would like to tell you that if you are much intelligent and if you write the formula for the gravitational force Fg m1 m2 by r squared, then you are capable of explaining the entire characteristic of this forces. So one thing is now of great importance, that it exists between all kind of masses, right? And according to the Einstein, I would like to tell you that not just this thing, but gravity affect both space and both space, matter and energy. Yeah, space and time, or simply I would like that it affects space and energy also, right? That it bends space and it just affect the energy also, right? So this is such an important force. But shortly, I'd like to tell you that it is the force of pull between all kind of masses. Means that the gravitational force, it is attractive only. It is attractive only. It is attractive only. This force is what? This force is attractive only. This force obey the law of product of masses, law of product of masses, and the inverse square law, and the inverse square law, the inverse square law. Here, as I told, that very simple, that when you were in class 9th, your teacher told that the gravitational force is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between their centers, right? So this force does not depend on the mass of a single body, rather it depends on the mass of the two. So if you have 1000 kilogram of body and if the other end you have 1 kilogram of body, so they both exerts the same force on each other, right? So force will be the same between them. This force is independent of the medium, like electrostatic force, independent of the medium, independent of the medium between the bodies, between the bodies. For example, you see, if you have, look, for example, if you have one body like this and if you have the other body like this, as you see, if this is body of mass m1, this is body of mass m2, and let if the distance center to center distance between them is, let's say, r, right? Then whatever is in between these two, for example, if there is air, if there is water or whatsoever, the force is not going to be affected. Whatever is the force, it can be calculated by this expression. So it is medium independent. Why? It is because the gravitational constant is medium independent. Nowhere, no way, wherever you are, but when there are two bodies, so the force that exists between them is independent of the medium. This force, it is a field force. It is what? It is a field force. It is a field force and can act between bodies without any physical contact, without any physical, without any physical, without any physical contact. What we can say is action at a distance. Action at a distance. That this is the kind of force which acts at a distance, right? So this is a field force. They interact through field, right? There exists a gravitational field around any massive objects, whether the mass is as big as the heavenly bodies or as small as the speck of dust found on your boot or even an electron, right? Since it is the characteristic of what? The material objects. So this is why that this force is a field force. The gravitational force between two bodies interacts when their field interacts, right? So around each body, there is what, for example, if it is mass m1, then it has a field, right, as I'm doing here and here. Similarly for this body also. So when the fields of the two body interacts together, then when the fields of the two bodies interacts together, then what happens, then they exerts a force on each other. So this force acts at a distance, means require no physical contact, no touch. So that is one of the important aspects of this gravitational force, right? This is usually this force is a long range force, or strong, that is long range force, long range force, right? Usually sometime I call that they can act at infinite distance also, though the force will be very small. Long range force means that this is one of the reason that they act between heavenly bodies, and this is why they keep the universe together. The next important point is this force is central. This force is what? This force is a central force. A central force means the force is central, means that they act along the line joining the center of the two bodies. So that is why this is called the central force. This force is medium independent. Did I write? Okay, yes, independent of the medium independent force. This force is the weakest in nature, the weakest in nature. For example, this force exists between you and any body sitting near you when you are listening to my this lecture, or that is it exists between you and your that laptop or that mobile phone, but you do not feel any sort of attraction. Why? Because this force is very weak, since our masses are small, and the weak nature of this force is due to what? It is due to the smallest value of what? The smallest value of g. Value of g. G means gravitational constant, which you know that it is 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square. So that is body must be large enough or heavy enough, not large enough, heavy enough to counterbalance this very small value. This is why I told that this force is usually astronomical. This is much more visible in case of the heavenly bodies. For example, you can easily, or things can easily be attracted towards the earth rather than towards each other. So that is one of the reason, because that if masses are greater, then you can overcome this small value of forces. For example, if you have two masses, if this is 1 kilogram, this is 1 kilogram, and if they are 1 meter apart, then what will be this force? Then this force will be just 6.67 into 10 to the power minus 11 Newton, which is very, very small, and rather I would like to say that not measurable. So that is one of this reason. The ratio of the electromagnetic force and the gravitational force, for example, that this is so small that the ratio of the gravitational force to electrostatic force is of the order of 10 raised to the power minus 43. This is what I calculated for two electrons of, right? Those two electrons masses you well known if they are 1 meter apart. Then if you calculate the electrostatic force between the electron and between those two electrons, and if you calculate the gravitational force between those two electrons which are 1 meter apart, then the gravitational force will be this much times smaller, or you can say that the electrostatic force will be 10 raised to power 43 times larger than the gravitational force, right? So this is why it is a very weak force. The second important point, not the second, another point is that is the, since I'm not writing the numbers, that is the, it is conservative, it is a conservative force, and you already know about the conservative force. By the conservative force, I mean that 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 is that the work done is independent on the path followed. Work done is independent on of the path followed. Path followed. Work done is what? Independent of the path followed. Right? Or that is work done around, or work done around the closed path is zero. Around the closed path is always zero. So if you move a body around a gravitational field, then the work done will be independent of the path followed, right? So that is the that is all about the gravitational force. There could be much uh, about them, but this is what I just told to you, maybe enough for you. The next one is the electromagnetic force. The electromagnetic force. The second force is the electromagnetic force. Okay, now just got another point here, very important point. That is the mediating particle for this force. They are exchange. That is the this force, the gravitational force. Let me write it here with this one, as I have forgotten. Now that is mediated by a particle called graviton. Mediated by the particles called graviton. Called graviton. Graviton is not yet discovered. However, the gravitational waves, which was predicted by Einstein after his 100 years of his production, the gravitational wave were discovered, right? So the mediated particle, they are not discovered yet. So this force is exchanged by the, this force is exchanged by the, this force is exchanged by the this force is exchanged by the particle called graviton. The next one is the electromagnetic force. This electromagnetic force is also called the Lorentz force. The Lorentz force. That is called the Lorentz force. The electromagnetic force, they acts between charged particle. I'm sorry. Acts between charged particles. They acts between what? Charged particle. Unlike the attractive force, it is the gravitational force, both attractive. This force is both attractive and repulsive. Both attractive and repulsive, and that is also obey the inverse square law, inverse square law, and the law of product of charges, and the and if we talk about the magnetic force, then the strength also. I would like to tell you that it is the a combined force that of electric and magnetic force, since I'm not explaining them separately. But one thing which I would like to tell you, that charge can exist separate, but remember, magnetic poles cannot exist separate. There is no concept like monopole magnets. Okay, and I explain electric force and magnetic force in great detail during my lectures when I was teaching those units to you. So this is why I don't want to explain it even further. These forces are can be felt from infinite distance also. Like gravity, they can be felt from infinite distance also, from infinite infinite distance also. And the second important point is that is this force is, as I told you earlier, this force is stronger. This force is stronger than gravitational force, than gravity. And this is one of the reason, then when you move or when you rub your hairs with a comb, then it can easily attract small pieces of paper because of this electrostatic force. So that is much more visible. We can experience this directly even. So this shows that it is much more stronger. But this force is macroscopic, while the above force is microscopic. For example, that over a larger distance, this is not that much visible. Okay, and like in the same way that if you write the formula for the gravitational for the electrostatic force E1, and similarly for the magnetic force also K. And if you just write this Q1, product of charges, into inverse square R, then you can explain the entire properties just if you look into the formula. Unlike that, this force is medium. This force is medium dependent. It is what? Medium dependent, and this is why it can be shielded. This force is medium dependent. Why? Due to due to K, the constant of proportionality. This is not the same everywhere. It changes with change in medium. So it depends on the nature of the medium. Since why it is medium dependent? Since K depends on the nature of the medium. Depends nature on the nature of the medium. So that is one of the reasons that is one of the reason that it's medium dependent. Like this forces also, this forces this forces conservative in nature. Conservative in nature. This is also field force. This is also a field force, and I introduced you to the concept of the field force in the previous one. Let me create some space here. This is what I will be explaining to you in a summary, inshallah. I place it for me. So that is what it is, a field force, right? This is what this is also a field force. Now there is two part to this force. The EM has two components: the electromagnetic force, electromagnetic force has two components, right? Because it is a unified force. In the two components, what's one such component is electrostatic force, and contrary to this, the other force is magnetic force. I give a very much detail of these two forces in their respective units, but here I just want to explain them again very little. The electric force, this force exists between charges, between charges, whether whether at rest or moving, no matter. Right? The force indeed does exist. While magnetic force, that is, this force is that once the charges are in motion, the charges are in motion. Once the charges are in motion, they display they display the magnetic force. They display the magnetic force. The magnetic force resulting or creating a magnetic field, creating magnetic field. So you see that this is the one of the difference between the two. They are just the complement of each other, right? They do exist together, right? Whenever charges are in motion, they constitute magnetic field around them, right? So that is the characteristic of the electrostatic force, and this is what this force is responsible for keeping the atoms together. They keep or bounds the atom together, bounds the atoms together, right? They maintain the structure of the atom, so molecule and so matter, so like gravity, and this is also very important. Now in my list, what is the next? The next is the weak force. But before the weak force, let me explain to you the nuclear force first. The nuclear force, because it is important to understand this first. The nuclear force are the strong force, sometimes it is also called the short range force. The short range force. This is, I think, predicted by Yukawa, a scientist from Japan in 1935, right? And I give a brief introduction to this to you also in the beginning of this chapter, where if you remember, I told you the F proton, if there is strong repulsive force between them at a distance so small as 10 to the power minus 15 meter, one nuclear radius, then why they do not repel each other? They must smash each other, but still they are together there, they live together there. And then I told that what could be the possible reason, and I told you that there might be a force that may be much more stronger than that Coulomb repulsive force, and that force is the nuclear force. So nuclear force is in fact the kind of force which keeps nucleon bound in the nucleus. This force keeps nucleon, the constituents of the nucleus like proton, neutron, bound, keeps the nucleon bound in the nucleus, in the nucleus, keeps the nucleon bounds in the nucleus, right? And this force is important for maintaining the structure of the nucleus, important for the what? For the stability of the nucleus, of the nucleus, right? This force is short range force, short range force. The force is what? Short range force means that it can act with an order of 10 to the power minus 15 meter. Once the distance becomes greater than this, it vanishes over a longer distance. Vanishes over a longer distance. Over a longer distance, if the distance increases, this force decreases. Right? That is strongest in nature. Strongest in nature, much more stronger than electromagnetic force and the gravitational force. It is only attractive. This force is what? Only attractive force. And attractive, but and charge independent. What? And charge independent. And charge independent force means that it exists between pp, exists between nn, neutron and neutron, and can exist between proton and neutron. So it is charge independent, and this is why it causes the stability of the nucleus, right? This is non-central force. Non-central force means does not necessarily act along the line joining the center of the two charge particle, right? Then this is all about the nuclear force. Okay. The next one is the next force is the weak force. The weak force. The weak force, now some, it is also called the electroweak force. Why? Because it was unified in 1969 by a Pakistani Nobel laureate scientist, Dr. Abdus Salam, and there was another one, Weinberg, I think. So they have combined the electrostatic force with a weak force, now known as the electroweak force. So we are not talking about the unification of forces, as the scientists still try to unify all the forces together. For some they successful, for some they are not. Now what is the weak force? Weak force acts inside the individual nuclei. Now this will be very strange to you. Acts inside what? Inside the individual nucleon. The individual nucleons. Nucleon. Now, for example, if you just see, look at, for example, if we have the proton, or if we have the neutron and the electron. Electron is the only particle which is fundamental in nature, right? It is not made of any other particle, while proton and neutron, they are composite particles. They are made up of what? Quarks. Quarks. They are made up of what? Quarks. So the proton is being held by this weak force. The particles of the that particles are called what? They are called the quarks, right? So they are not the composite, they are made up of other particles. Again, I have forgotten that the nuclear force, they can be mediated by the particles. I think they are mediated by the pions, right? You just check that too. So there is also, since they are field forces, so they are mediated by exchange particles. Now that is the next important point is that it is even shorter in range, even shorter range than even shorter ranged than the strong nuclear force. Then the strong nuclear force. Why? Because it acts within the individual nucleon. So that is its dimension must be that of the proton neutron like that. So it can act within the range of 10 raised to the power minus 8 meter, much smaller than that of the range of the nuclear force. So this is why they are called the weak force, that is much weaker than the short range force and the electromagnetic force, much more weaker than the EM and nuclear force, EM electromagnetic force and the nuclear force, right? And this force is mediated by boson, mediated by mediated by the particles called boson, right? So this is also, these are known as, sometimes known as exchange particles. What? Exchange particles. That this force can be exchanged by these particles, right? So the this force is neither attractive nor repulsive. Very strange thing. Neither attractive nor repulsive. They only hold the individual nucleons together. And this force, the most important point is it is responsible for beta decay, right? Beta decay is the result of this force. So this force causes what? Changes. Because of this forces, that is neutron changes to proton, neutron changes to what? Changes to proton, or proton changes to neutron. Okay, and if this happens, then this will be the beta minus decay, and this will be the beta plus decay, positron electron emission, which you might have heard, right? So this is all about the weak force. Now let me summarize this. This is the strong. Here you see the strong binds, and the strong force binds the nucleus, right, for the stability of the nucleus, as you see here. Look, as you see here, the electromagnetic force hold the structure of what? The structure of the atom. The nuclear force hold the structure of the nucleus. The weak force is causing radioactivity, responsible for the radioactivity, and the gravitational force is what binds the solar system, or the much astronomical system. The gravitational force, as I told, weakest, attractive, affect anything with mass, and it is long range. This is why I told that massive. Electromagnetic force, strongest, attractive, repulsive force, effects within charge, magnetic properties, long range. For the strong nuclear force, I told, strong, attractive, holds nuclei together, short range. Weak nuclear force, the third strongest, neither attractive nor repulsive, changes nucleus, short range within the nucleus, as I told, that for the making of neutron and proton, which are the composite particle, unlike the electron, which is the fundamental particle. So here the forces, its strength, its range, and its the command strong nuclear force, very strong, very short range, effect protons in neutron only. Electromagnetic force, strong, infinite range, affect all objects with static or moving charges. Weak nuclear force, weak nuclear interaction or weak force, weak range is this, affects all particles. Gravitational force, very weak, infinite range, affect all the particle, weak because of small g, as I already told. But when it comes to the massive objects, not weak, stronger, right? So this is all about the basic forces of nature. I hope you might have understand the today lecture. So there is remaining one last topic of our scheme of studies, and that is the fundamental particles. So inshallah I will discuss in my next lecture. So this is for today. Thank you very much for being here. So inshallah see you in the next lecture.